talked about sig figs, but now we're going to start talking about energy. And so energy changes when it relates to matter, different types of energy. So before we start talking about energy, let's define what energy is. So this is our chemistry definition of energy. So energy is the capacity to do work. So energy is the capacity to do work. So I use the term here, work. And so you might know what work is. You're like, oh, I do schoolwork, I work hard, or I work out, or whatever. But work is a technical term in physics and chemistry. So we need to define that so that we make sure we're on the same page. So the definition for work is the action of a force applied across a distance. So the action of a force applied across a distance. So then you might be asking yourself, okay, you now have to define another word. What is a force? Okay. So a force is going to be a push or a pull on an object. Okay, so let's talk about this. So energy is the capacity to do work. So work is being able to push or pull an object and it go across a distance. So the question would be, do I have the capacity to do work? Do I have the capacity to push something or pull something across a distance? Yes. But we need to see, well, am I actually doing it? Okay? So let's see if we're actually doing any work. So we only do work if it actually moves. So if I come up here and I push on this board, I push really hard, push with all my might, is this going to move? It's against the wall, it's like it's like nailed into the wall. So no matter how much I push and push and push, I'm not going to be able to move this object. Okay, I might get really tired from it, but it's not going to make a difference, right? Okay, so no matter how much pushing and how much force I apply, if it doesn't move across a distance, I've not done any work. Okay? Another example is I could come and I could take something that is kind of light. Like I have like this little wheelie desk here. I don't know if you can see it. Yep, you can see it. It's where I've got my little surface on, so this is where I write on. So that's what I'm doing over there when I walk off the screen. So I'm writing on my surface so you can see it on the board, and so that I don't get in your way. So this is wheels. So I can push on it, and look, it moves. So I've applied a force, and I've done work, okay? Now, I didn't have to apply a very strong force for it to move. Some things require a stronger force for you to actually do work, okay? All right, I'm gonna put this back. Okay, now, this is talking about pushing and pulling something, and you might be thinking, like, this is a very physics-oriented definition. But in chemistry, we still have things that are gonna be moving. So remember, we have these little atoms, little molecules that are moving around, and so they're gonna be hitting things and interacting with things. And so we think about this the same, but instead of us pushing some object, we're gonna think about it from a chemical standpoint. This molecule or atom hitting something else and interacting with it in that sense. All right, so let's think a little bit deeper about our energy. Okay, all matter possesses energy. All matter. All matter possesses energy. And we'll talk about this a little bit more when we start talking about the fact that there's atoms and molecules in everything. Okay, so everything. I possess energy, this board possesses energy, the air in the room possesses energy, the pencil that you're holding, or pen, that you're holding right now, everything possesses energy. Now, there are two different types, okay? So these are the two different types of energy. And we're gonna talk about each of these two types on the next two slides, okay? So there's kinetic energy and potential. And remember, we already talked about kinetic a little bit when we talked about temperature. We talked about this being that energy of motion, but we'll talk about it a little bit more. Now, when we talk about energy, energy can do a couple of things, okay? One of the things that it's mainly going to do that we're going to see in this chapter is it's going to convert from one form to another. And so I might have kinetic energy, and then it might convert to potential energy. Or my potential energy might convert to kinetic energy. Okay? Another thing that it can do is matter can go from one thing to another. So if I push, I can take my energy and I can push my energy against this wall. Okay? So, or somebody could push you, and then their energy is going to be exchanged from them to you. So energy can go from one form to another, or from one object to another. So what we're going to talk about a lot is whenever something undergoes a chemical or physical change. So if we're doing a reaction, or we're burning something, or it's going from a solid to a liquid, or any of those things, the energy is going to change. So pretty much everything in chemistry, because it's doing something, is going to have an energy change. It might be going from one type to the other within itself, or going from one thing to another. All right, so let's talk about our kinetic energy. So kinetic energy is our first type of energy. Okay, and we already kind of hinted at this when we talked about our temperature. So let's write down our chemistry definition of kinetic energy. So this is the energy of motion. So we talked about that energy of motion when we talked about temperature, but it's also energy of motion or energy that is being transferred. Energy of motion or energy that is being transferred. So we're going to look at this example with our pool cue. So if I hit the pool cue, it's moving. So if it's moving, it's got kinetic energy. This guy's not moving, so he doesn't really have any kinetic energy. Whenever this pool cue hits the ball, now the energy is going to be transferred. It's going to transfer from the cue ball to the purple ball. Okay, so energy that's being transferred is still kinetic energy. Now my purple ball is moving, so now he has kinetic energy. So think about energy of motion or energy of transfer. Now this is with pool cues, pool balls, sorry. But in chemistry, we've got atoms and molecules that are going to hit each other. They're going to be moving, and then they're going to collide. So same kind of idea we have here, but with atoms and molecules. Now, when we talk about with chemistry, you might have different types of kinetic energy. Where do we get this energy for motion or being transferred? One way you can think about it is you get energy from like eating food and those kind of things. But when we're talking about our chemistry kind of things, reactions of those kind of things, where we get that kinetic energy is mainly going to be a subcategory called thermal energy. So thermal energy is a form of kinetic energy because it is caused by molecular motion. So thermal energy is the energy caused by molecular motion. So in this case, it's not talking about an object like this moving. We're talking specifically about, so this would be like a general object, anything moving. Here we're talking about the motion of a molecular, so anything molecular motion. So we're talking about our atoms and our molecules. So we're being specific about what is moving. So anything that has atoms and molecules is going to have thermal energy because those atoms and molecules are moving. So because the atoms and molecules are moving, they're going to have kinetic energy. That energy is specifically thermal energy. And that's the energy that we take when we take a temperature. Okay? We're measuring the thermal energy. So if you've ever had one of those like temperature guns, they're really common right now, especially with COVID, because you don't want to get close or share a thermometer. So those like laser temperature guns, you could shoot it on your head and you might sense like, okay, I should have a temperature. And you could shoot it like on a dog, not in their face, and they should have a temperature. But if you've ever done it against the wall or against the table or the chair, or whatever, it's also going to have a temperature because everything is made out of atoms and molecules. So if everything is made out of atoms and molecules, those atoms and molecules are always moving, some moving more than others, but those atoms and molecules are always in motion. So since there's always molecular motion, you always have kinetic energy, you always have thermal energy, so you always have some sort of temperature. Now how much? Remember temperature, the more the kinetic energy, the higher the temperature, okay? So this is where we're able to measure the temperature based on our thermal energy. All right, so we're gonna stop this video here, and on the next video, we'll talk about our second type of energy, potential energy.